This is SpaceTime Series 21, Episode 65. Coming up on SpaceTime, the hydrogen wall at the edge of the solar system. After a break of 7 years, America is about to resume launching people into space off American soil. And Yellowstone's super-volcano may just have revealed some of its secrets. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Observations by NASA's New Horizons spacecraft has identified what could best be described as a hydrogen wall at the edge of the solar system. The findings, reported in the journal Geophysical Research Letters, supports a similar discovery made 30 years ago by NASA's twin Voyager spacecraft. The new scans, recorded by New Horizons ultraviolet spectrograph ALICE, detected an ultraviolet glow at the edge of the solar system. A constant stream of charged particles generated by the sun, known as the solar wind, causes hydrogen atoms in the space between the planets to release characteristic ultraviolet light. However, the strength of that ultraviolet glow tends to fade the further away you are from the sun. The twin Voyager spacecraft, and now New Horizons, have detected a sudden increase in ultraviolet light near the edge of the solar system, thought to be caused by the presence of atomic hydrogen at these characteristic Lyman alpha emissions, where the solar wind collides with interstellar winds from elsewhere in the galaxy. You see, the solar system moves through the galaxy in the sun's solar wind bubble called the heliosphere. Uncharged hydrogen atoms floating about in interstellar space slow down when they collide with the solar wind particles. These interstellar hydrogen atoms then pile up, forming a cloud or so-called hydrogen wall, which again scatters ultraviolet light. New Horizons, the first spacecraft to have travelled far enough out from the inner solar system to be in a position to confirm the earlier Voyager observations. NASA's Voyager 1 spacecraft passed through the edge of this heliospheric bubble and into the interstellar medium on August 25, 2012, at a distance of 121 astronomical units. An astronomical unit is the average distance between the Earth and Sun. It equates to about 150 million kilometres or 8.3 light minutes. The authors are expecting the ultraviolet light levels to eventually drop off again after New Horizons passes through the wall. However, if the light doesn't fade, that would indicate a different ultraviolet source, something coming from far deeper in the galaxy. New Horizons was launched back on January 19, 2006 from the Cape Canaveral Air Force Station in Florida aboard an Atlas V rocket. The probe made history on July 14, 2015, when it became the first spacecraft to visit Pluto, flying just 12,500 kilometres above the 2,377 kilometre wide dwarf planet's surface. The probe also studied Pluto's binary partner Charon and their 4 moons, Styx, Nix, Kerberos and Hydra. Pluto is one of the largest known bodies in the Kuiper Belt, a ring of frozen worlds, comets and icy debris circling the Sun out beyond the orbit of Neptune. New Horizons' next close encounter will be on January 1st next year, when it undertakes a close flyby of the 30-kilometre wide Kuiper Belt object 2014 MU69, Ultima Thule. You're listening to SpaceTime. I'm Stuart Gary. Okay, let's take a break from our show for a word from our sponsor, The Great Courses Plus. Like you, I love the joy of learning, and that's what I get by watching and listening to The Great Courses Plus. I get to explore topics that fascinate me, and I learn from award-winning experts. With The Great Courses Plus, you can learn about anything that interests you, explore the stars, discover more about people and places through history, find out how to better understand human behaviour, even learn how to draw. There are over 10,000 lectures to stream on heaps and heaps of different topics, with more being added all the time. And with the Great Courses Plus app, you get to watch or listen anywhere, anytime. And to get you started, I can recommend a course that I've really enjoyed on radio astronomy. It's called Observing the Invisible Universe. It's presented by radio astronomer Professor Felix Lockman. He explains the remarkable technology behind radio astronomy and the distant parts of the universe explored through radio waves. Things like pulsars and quasars, supernovae and much more. Observing the Invisible Universe is covered in 25 lectures, with topics like the birth of radio astronomy, radio telescopes and how they work, the importance of hydrogen and the structure of galaxies, pulsars and gravity, the Big Bang, the oldest radio waves, and so the list goes on. This course will give you a fantastic grounding on this fascinating subject. It's the perfect course to get you started from the Great Courses Plus. Or if you prefer, enjoy one of their other fantastic lectures with our special offer, a free trial for unlimited access to the Great Courses Plus entire library. So get started now by signing up to our special URL. Sign up for your free trial at thegreatcoursesplus.com/space. That way they'll know you came from here and you'll be supporting our program. That's thegreatcoursesplus.com/space, and of course we'll put that link in the show notes. thegreatcoursesplus.com/space. And now it's back to the show.
You're listening to SpaceTime with Stuart Gary.
NASA has assigned its first crews to the new Dragon and Starliner capsules, marking the return of America to the business of flying people into space from American soil. That's something that hasn't happened since NASA prematurely axed the Space Shuttle program 7 years ago. The last Space Shuttle flight was Atlantis on mission STS-135, which returned to Earth on the 21st of July 2011, ending the Delta Wing spaceplane fleet's 30-year career. The early mothballing of the Space Shuttle fleet forced NASA to fly its crew to the International Space Station using Russian Soyuz rockets. And once NASA was in the market for Soyuz seats, the price of a ticket on Soyuz suddenly rose from $20 million to $67 million a seat. Meanwhile, NASA announced what they called their Commercial Crew Transport Capability Program, a call for private contractors to develop their own spacecraft to taxi crew and cargo to the International Space Station. Eventually, Orbital ATK Cygnus, launched by their Antares rocket, and SpaceX's Dragon, launched aboard a Falcon 9 rocket, were awarded NASA's Commercial Resupply Services contracts to fly cargo, supplies and equipment to the space station. And the two will soon be joined by a third operator, Sierra Nevada's Dream Chaser spaceplane. Around the same time, Boeing and SpaceX also won contracts to ferry crew to the orbiting outpost. For that mission, SpaceX developed a human-rated version of their existing Dragon cargo ship, to be known as the Dragon 2. The reusable spacecraft's designed to ferry up to 7 astronauts on missions to low Earth orbit, and is equipped with computer tablet-like swivel-mounted control systems for optional crew control by a pilot and co-pilot. The Dragon 2 capsule is equipped with a set of 4 side-mounted thruster pods, each using 2 3D-printed Super Draco hypergolic liquid-fueled rocket engines. The pods will act as both the spacecraft's main propulsion system, its reaction control system, and its launch escape system. Although initially landing under parachutes, the Dragon 2 could eventually use its Super Draco engines for a full propulsive landing from orbit. The Dragon 2 is slated to conduct its first automated test flight to orbit aboard a Falcon 9 in November, and the first crew flights are expected to travel aboard the capsule in April next year. Meanwhile, Boeing and Bigelow Aerospace jointly developed their own space station crew transport vehicle, the CST-100 Starliner capsule. Starliner is similar in appearance to both NASA's new Lockheed Martin Orion Deep Space Man capsule and the older Apollo moon rocket command module. Overall, the Starliner is a bit smaller than Orion and a bit bigger than Apollo. Starliner will also be reusable. It'll also carry up to 7 crew into low Earth orbit. It's designed for missions lasting up to 7 months and will be capable of being launched either on Atlas V, Delta IV or Falcon 9 rockets. The Starliner will undertake its first automated test flights around April next year, with its first manned flights expected by the middle of 2019. Interestingly, Starliner will use an airbag cushion ground landing system to return crew to Earth, rather than the usual American practice of landing on water. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson from the Department of Science.
NASA has announced they'll be doing the first all-US space launch since 2011, which is very exciting news. That'll happen next year, but they've basically rolled the crew out.
That's correct, Andrew. So this is pretty exciting, I think, for everybody. Of course, the Space Shuttle retired back in 2011. The last flight was by the Space Shuttle Atlantis, and there have been no US launched astronaut missions since then. All the astronauts who've been ferried up and down to crew the International Space Station, and that happens pretty regularly, they've been carried up there by Soyuz spacecraft of Roscosmos, the Russian space agency. And the Soyuz, well, a workhorse of human spaceflight since the 1960s when they were developed, but it is time for new technology. And the shuttle, it was the right decision to retire the shuttle. What happened was NASA at that point decided that what they wanted to do was basically buy launch services or ferry services for astronauts so they could concentrate on really cool stuff like building spacecraft to take people to Mars and things of that sort. So that's what's happened. And there are two main agencies or companies who have provided the capsules, and they're both well established. Their technology is well tried. Both have launched many times, just cargo spacecraft up to the International Space Station using the same technology. But as you said, next year, these two companies will send the first space flights with astronauts on board. So the reason why this is a big story is because of that, but also that the sort of cadre of astronauts who will take those missions has been announced. There are 9 of them. And I think I'm right in saying that all but 3 have flown before. And in fact, some of them were on the final shuttle mission. There's a whole range of different experiences, but most of these people have been in orbit. I think there are 3 newbies, and I'm sure they will meet up with the standards that are required. They're not all men. There's a couple of women among them as well, which is great stuff. So the technology that we're dealing with here, 2 companies, SpaceX and Boeing. Boeing have been working on their capsule, which is called Starliner. So Starliner will, I believe, make its first crewed flight in the middle of next year. They haven't quite yet fixed the date, whereas I was going to say the opposition, but I don't think they are the opposition. These companies have worked pretty closely together, even though they are quite independent, and their spacecraft are quite different in appearance because they've been designed for different things. SpaceX, of course, Elon Musk's company, often in the news. Their capsule, which is called Dragon, has been used many times to take things up and down to the International Space Station. But in April next year, possibly before Boeing's first flight, in April they will take their first crew up to the International Space Station. And probably both of these flights will probably be fairly short-lived, just to try the technology, make sure everything works before there are proper ferry services up and down to the space station, which is really what this is all about.
Yeah, I suppose it's a bit like a back to the egg scenario, like the Apollo missions. The first just a few laps around the planet, and then they ventured out further, and then Apollo 8 did that famous lap around the moon. I think it was 8, and then
it was Apollo 8. Look, that was one of the highlights of my life at that time. They orbited the moon on Christmas Day 1968.
That's right.
Took amazing photographs. Yeah,
and of course then that culminated in the famous landing of Apollo 11, which is nearly 50 years now, coming up on 50 years next year.
It will be, correct.
Which is very exciting. And so this is sort of the same deal. They're just going to test this gear out, send a few people up, have them sort of float around for a couple of days, and then bring them back. And ultimately, once they've ironed out any bugs or issues, they'll be ready for business.
I think that is the case, and it's exciting stuff. As I said, I think we're opening up a new pathway in human space exploration, which is very exciting and involves the commercial sector. That's the big difference between this and what happened before. Companies like Boeing were certainly involved with the lunar landings, but it was all very much under NASA's control. It wasn't just a service that you can buy, which is what they're aiming for now.
Yeah, and I suppose it wasn't really feasible long term for governments to bankroll these things. It had to go private ultimately, didn't it?
Yeah, that's right. Indeed, that's right.
And there's probably money to be made eventually in some form or another. I mean, it's got to be a profitable venture. Otherwise, it's just never going to work.
That's right. And there are all kinds of prospects. There's tourism is one.
Yep.
The mining asteroids and possibly the moon is another. All of these things are things that could potentially make money. It's long-term stuff, though. There's not going to be huge profits the day after tomorrow.
Well, as we've previously discussed, something like mining the moon or asteroids is probably 100 years away. It's not, but they have to do the groundwork now to make it feasible in 100 years' time. If we don't start now, then will take another 100 years if we wait 100 years. So,
so I don't know to what extent that is absolutely going to happen, and a lot depends on what these asteroids are made of. But I bet it's less a smaller timescale than that, Andrew. I think we're more like 20, 30 years, something like that.
That's still a long way off, but yes.
It's a long way off, yeah.
They've got to
it is when you're 115, I can tell you.
That's Dr. Fred Watson from the Department of Science speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. A new study claims the Yellowstone super-volcano eruptions were produced by the subduction of an ancient oceanic plate rather than mantle plume hotspots. The findings, reported in the journal Nature Geoscience, mean the long-dormant super-volcano in the American West has a different history than previously thought. Scientists have long hypothesized that Yellowstone's caldera, part of the Rocky Mountains and located in Wyoming, is powered by heat from the Earth's core, similar to the mantle plume hotspots driving Iceland and Hawaii. However, this study's lead author, Associate Professor Ying Zhao from Virginia Tech, says that her research indicates there's simply no evidence of a mantle plume. Instead, her new underground images suggest the Yellowstone volcanoes were produced by a gigantic ancient oceanic plate which dove deep under the western United States about 30 million years ago. This tectonic plate then broke into pieces, resulting in perturbations of unusual rocks in the mantle, which led to the Yellowstone volcanic eruptions over the past 16 million years. Yellowstone's last super eruption was about 630,000 years ago. Zhao describes the eruptions as very explosive. To reach their conclusions, Zhao and colleagues developed almost X-ray-like images of the Earth's deep interior, using the US Array, which is part of the EarthScope project being funded by the National Science Foundation. The system uses strategically placed seismometers across the United States to see structures deep within the Earth when an earthquake occurs. The vibrations spread out and create waves when they hit rocks. The waves are then detected by the seismometers and are used in what's known as diffraction tomography. In this study, the authors found an anomalous underground structure at a depth of between 400 and 650 kilometres right beneath the line of Yellowstone volcanoes. Zhao says this new evidence is in direct contradiction to the long-respected plume model. In her study, Zhao found that new images of the Earth's deep interior showed that the oceanic Farallon plate, which used to be where the Pacific Ocean is now, wedged itself beneath the present-day western United States. The ancient oceanic plate was broken into pieces just like the seafloor of the Pacific today. A section of the subducted oceanic plate started tearing off and sinking down into the deep Earth. This sinking section of the oceanic plate then slowly pushed hot materials upwards to form the volcanoes that now make up Yellowstone. That series of volcanoes that make up Yellowstone have been slowly moving, achingly so ever since. The process started on what is now the Oregon-Idaho border about 16 million years ago, and it's propagated in a northeastwards direction, forming a line of volcanoes that are progressively younger as they're stretched to the northeast into present-day Wyoming. The mantle plume model had been used to explain the unique Yellowstone hotspot track, the line of volcanoes in Oregon, Idaho and Wyoming that dot parts of the Midwest. If the North American plate was moving over a fixed mantle hotspot plume below what is now Yellowstone, it will displace the volcanoes towards the Oregon-Idaho border and form a line of volcanoes, but such a deep plume hasn't been found. The big question now is, if Zhao's correct, then what's really causing the volcanic track? In order to try and answer that question, the authors plan to increase the resolution of their images. More detailed images of the unusual rocks in the deep Earth will allow Zhao and colleagues to develop new computer simulations to recreate the fragmentation of the gigantic oceanic plate. They'll then be able to test different scenarios of how rock melting and magma feeding systems work for the Yellowstone volcanoes. I'm Stuart Gary. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new analysis of some 18 separate studies has concluded that taking multivitamin and mineral supplements does not prevent heart attacks, strokes, or cardiovascular death. The findings, reported in the American Heart Association's journal Circulation, Cardiovascular Quality and Outcomes, put together results from 18 individually published studies, including randomized controlled trials and prospective cohort studies, totaling more than 2 million participants and having an average of 12 years of follow-up. They found no association between taking multivitamin and mineral supplements and a lower risk of death from cardiovascular diseases. As many as 30% of Americans and a similar number of Australians use multivitamin and mineral supplements, with the global nutritional supplement industry expected to reach $278 billion by 2024. A trial of 40 children with hard-to-treat epilepsy has found that cannabidiol, a non-psychoactive compound found in marijuana, may have some positive effects, and with a manageable side effect profile. The trial, reported in the Medical Journal of Australia, involved treating kids who were part of the New South Wales Compassionate Access Scheme. Most of the side effects that were found were rated as mild to moderate and were considered unrelated to the cannabidiol itself, with sleepiness being the most common cannabidiol-related side effect. Both parents and doctors felt that many of the kids had improved in overall health, although the authors cautioned the trial wasn't really designed to be able to draw conclusions on efficiency. A new study claims fibre optic cables can be used to find and assess geological fault lines and monitor earthquake activity. The findings, reported in the journal Nature Communications, are based on the discovery that fibre optic cables in seismically active Iceland were able to detect both human and natural seismic signals, and could therefore be used to map surrounding faults and geological structures in detail. Seismometer networks are incredibly expensive to build and maintain, and so simply using fibre optic cables, which were already in place for telecommunications, could be a low-cost earthquake monitoring alternative, allowing geologists to cover more ground. Scientists have confirmed that new seafloor is created along tectonic plate boundaries, known as mid-ocean ridges, through the upwelling of fresh mantle material from beneath transform faults. The findings, reported in the journal Geophysical Research Solid Earth, provide the first global evidence of how mantle flow beneath oceanic transform faults convert the ridge segments of divergent plate boundaries. A fundamental feature of the seafloor spreading is the formation of the transform faults. The characteristic ridge transform geometry is a key component of plate tectonics and governs the creation of new seafloor. Mid-ocean ridges have been important sites, potentially holding clues for the origins of life on Earth. In fact, unique ecosystems exist along these ridges around volcanic hydrothermal vents. Mid-ocean ridges are also sites known to produce precious metals, such as gold and copper. When the heated water is released from hydrothermal vents at these sites, it precipitates mineral deposits onto the surface of the seafloor. Most of planet Earth's crust, both now and in the past, was formed along the global mid-ocean ridge system, where two oceanic plates are pulled apart. The scientific method involves observation, hypothesis, experimentation, analysis, and conclusion. Science is all about critical thinking. It's a search for the truth. Don't just take someone's word for it. Test the claim. See if it's factual and stands up, or if it's really just a great steaming pile of woo. That's what skepticism and evidence-based science is all about, a search for the truth. And remember, scientific facts don't care if you like them or not. The peer review process is one of the most important cornerstones of science. It's designed to allow research results to be replicated independently by other scientists, thus assuring and confirming their accuracy. However, some scientists have either deliberately or through naivety published their results in pay-for-published journals, many of which lack peer review and therefore scientific credibility. Aran Segev, president of Australian Skeptics, joins us now to explain the problem.
The way publishing in science has traditionally worked is that the scientists would write up their work and they would submit it to journals. There are some very famous journals like Science or Nature, but there's also journals that are specific to areas of expertise. And these journals would then submit the work after some initial filtering to the peers of those scientists, to other experts in the field.
That is absolutely the key. The peer review process is what it's all about. If you have a scientific discovery, the idea is you then get it peer reviewed. That way other people will try to replicate the work. It just confirms that what you're doing is kosher, it's legitimate, and
absolutely.
The results are real.
Peer review is at the core of science. Beyond that, there's also the issue of publication is a very important part of how scientists progress in their career, and the accumulation of scientific literature is also what leads us towards the truth, because you have to remember that each specific article, each specific experiment by itself is a data point, but it is the accumulation of evidence as represented in the literature that really tells us what is the current state of the art. However, there was a problem with these journals, and that is that they're very expensive. A subscription to something like Nature or Science could cost thousands of dollars per year, so it is not accessible to the public generally. And that has led to a couple of things. First of all, there are things like Sci-Hub, SCIHUB. They publish it. You can look for articles on this website, and you will find articles for all these journals that are actually you're supposed to be paying to gain access to. But it also led to a legitimate movement of open access journals that instead of charging the public for access, the results, the papers are available to the public. And the sources of funding come from elsewhere, either from donations or from advertising, or very often from the scientists themselves. So this, instead of the public paying to access the science, the scientists pay in order to publish it. That, of course, leads to all kinds of potential problems. And one of them is that the science that is being published in those papers would not be legitimate. There are multiple open access journals that are completely legitimate and go through very rigorous peer review, just like the paywalled journals. However, there is a problem of predatory journals whose entire reason for existing is to charge scientists for publishing.
And that's
because
what this is about.
That's what this is about. It's about those predatory journals who are causing immense damage. First of all, because they charge scientists for what is essentially a scam. Scientists are paying money to publish in journals that have no impact and basically no relevance at all. But more importantly, it causes a situation where when you look online for research on specific subjects, what you will find very often are these fake articles that have nothing to do with this. They have not been peer reviewed. They can sometimes be completely fake, completely made up, but they look scientific. The names of the journals appear to be legitimate. And of course, it means that it's becoming increasingly difficult to know what's true and what's not true in the area of science.
And the other problem with these journals also is that they often rely on and I hate to use this term, but the gullibility of some scientists. Scientists are so entrenched in what they're doing, they're so focused on their work, they often are naive to some of the scams going on around them, which I know sounds really stupid when you're talking about a scientist who usually have a reasonably decent IQ. But it does happen. It happens to be a problem. And then once they've been hooked by one of these journals then there are problems when they try to publish their work in legitimate journals.
Absolutely. But look, we know from the area of skepticism, actually, the scientists are very often very poor at detecting scams because nature doesn't lie. So scientists are very poor at detecting lies. They're poor at detecting what's true and not true when they're just based on the evidence, based on data. But that's not the case here. We're talking about actual scams.
That's Aran Segev, president of Australian Skeptics. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.